Hi, welcome back. Now we have a demo on pointers, and this is going to be the first demo we have on pointers. So first of all, let's just keep this in mind for later in the demo, that the second argument to the main function is always a pointer to a character argv. So let's kind of unwrap this. We know that this car star thing really means a string. A character pointer could be a pointer to a single character, but it can also be treated as a string. Argv, therefore, is an array of strings. So if argc is the count of the arguments, argv is the actual arguments to the program at the command line. So remember that, and we'll come back to that in just a moment. So first of all, we want to declare an integer a. We do it just like that. We've always done it that way. Now we declare a pointer to a. This says assign PA the address of a. First, a is an integer, so PA needs to be an integer pointer, int star. Now, I put the star over here by PA. We could also put it by int, but the convention is to put the star along with whatever the name of the variable, the pointer variable, is. Car star is an exception. We tend to put the star with car to denote a string. PA equals address of A. Now PA points to A. That's how we say that. Now if we then, just out of interest, want to print the size of A and PA, that's pretty simple. Size of A equals a long integer, size of PA equals a long integer, and then we can get the size of A and the size of PA. What happened to parentheses on the size of? Well, size of really isn't a function. I lied earlier. To keep things simple, size of really is an operator. So it's a unary operator that gets the size of whatever follows it. So size of A will return 4. Size of PA is going to return whatever the size of a pointer is. All pointers are the same size. A equals 9. Now, this is an assignment. We already know what that does, but let's see if we can print out the contents of A, whatever the value of A is, the contents of PA, the address of PA, which is what PA is, it's an address, and the contents of memory at address of PA. So I've got that string set up here. Notice how I get the address of a pointer. %P gives me that as an address, and it'll give it to me as a hexadecimal number, a base 16 number. So I have A, PA, which is the address, and contents of PA. So let's stop there for now and print this out, or execute the program and see what we get. So we want to make pointers, and then we want to run pointers. So the size of A, the int, is 4 bytes. We knew that. Size of PA, though, look at this. It's 8 bytes. Pointers are always unsigned longs. So PA is 8 bytes long. Pointers are unsigned longs because they need to point to any address in memory. So now if we print out A, no surprises, we assign 9 to A. So printing out the value of A is 9. Printing out PA gives us that hexadecimal address. It is 3 bytes long, but it is the lower order 3 bytes of an 8-byte address. 0x just means this is a hexadecimal number. And then contents of PA is whatever A is, whatever the value of A is. So again, that's 9. So that's our first introduction into how pointers work. I have A, its value is 9, I assigned it. So contents of PA, contents of the thing that points to A, is also going to be 9. Another way to think of this is the contents at memory address 7FFF 5903 4B8C is 9. All right, so a little bit more. What if I change A? So I'm going to change A in an interesting way. I'm not going to change A, I could have done, but actually what I'm doing is I'm going to change the contents of PA, the contents of memory pointed to by PA. And if I print again, I should see the same kind of thing, except now A is going to be 4, PA is going to be the address that it was before, and contents of PA should be 4 as well. So let's make sure that happened. All right, so we see the size of stuff. In the first line, A was 9, so we see all that. In the second line, A is 4, but notice the address doesn't change. PA does not change because it's still pointing to the memory address of A. But the contents of PA, because I changed the contents of PA, A changed as well. A and contents of PA refer to the same thing. Address of A and PA refer to the same thing. All right, so let's keep going a little bit, see if we can learn a little bit more. So let's see, I'm going to get rid of that and put it here. All right, so now we're going to make a new pointer and point it to the address of A as well. So here we have a pointer called PA2. Now, if we print the contents of PA and PA2, we should get whatever is in A, which is 4. So PA, contents of PA, and contents of PA2 will be both be 4. So let's go ahead and save that, and we'll run it, make, and run. All right, so PA, contents of PA is 4, contents of PA2 is 4. So far, so good. So both things are pointing to A. Now, if I bump contents of PA, if I bump it by adding 1 to it, let's see what happens. PA plus equals 1. Now, if we print the contents of both pointers and A, this was 4 before. It should be 5 now. So let's see if that happens. Okay, make and run. So PA, contents of PA is 5, contents of PA2 is 5, and look at this, A is 5. So all I did here is change one value. I changed the contents of PA. It got incremented to 5, the contents of PA2 got incremented to 5, and A got incremented to 5. So by incrementing the contents of the pointer, I incremented the value of A, because the contents of PA and the contents of PA2 are the value of A. So two pointers pointing to the same physical address in memory, which has the label, the variable name, A. So let's do one more thing. Let's see if we can unwrap this car star thing. So car star argv is an array of car pointers, right? We have car star, it's a pointer to a car, and then argv with these square brackets, which says this is an array. So it's an array of car pointers. Or, another way to say that, we already kind of hinted at in the last demo that car pointers are strings. Another name for a character pointer is a string. So this is an array of strings. So let's assign something called argcount, the value of 0. And then for each argument, while argcount is less than argc, argc being this integer value here, the count of the arguments that we get, while 0 is less than 1, 1 is less than 1, and so forth, we print out argv at argcount, and that is going to be a string. So we give argcount this index, and we give argv argcount the string. And then we increment argcount. So now let's run that, and if we run it just with the name of the file, like this, look at this, argv0 is pointers. This is the first argument to the program, the runnable name of the program, /pointers. Now let's say that we instead do /pointers are fun. Now we get argv is 0 is pointers, argv at 1 is r, and argv2 is fun. So I proved it. Pointers are fun. Thank you.